morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So, in this session, I want to discuss about design of keys. So, how to design of a rectangular key and a square key or any type of key. So, how to design the procedure and the problem we will see. So, take this problem. So, design the rectangular key for a shaft of 50 mm diameter. The shaft diameter is given as 50. The shearing and crushing stresses for the key material are 42 megapascal and 70 megapascal. So, for the key material, the crushing and shear strength stress given 42 megapascal and crushing is given 70 megapascal. So, in this he has asked design the rectangular key. So, design means you need to calculate, you need to determine what are the dimensions of the rectangular key. So, you know the rectangular key having dimensions width, length and thickness. And also we have discussed how to calculate the strength of a key. So, by using those empirical relations in this problem we have to solve. So, first of all, given data, write down. The given data is diameter is 50 mm and shear strength 42 megapascal. This is convert into this 42 Newton for mm square. So, in mm square convert. So, already you know 1 megapascal is equal to 1 Newton for mm square. So, 1 pascal is equal to 1 Newton for meter square. So, 1 megapascal means 10 to the power of 6 Newton for meter square. In terms of mm, so 10 to the power of 6 divided by 10 to the power 6, it is converted into mm square. So, the length of the key obtained by considering the key is in shearing and crushing. When it is subjected to shear and when it is subjected to crushing, so calculate the torque and the length of the key. So, when considering shearing of the key, we know that the shearing strength or torque transmitted of the key. So, what is that equation? So, T is equal to L into width of the key multiply with the shear strength, shear stress and the D by 2, where D is the diameter of the shaft. So, in this we don't know L. So, width already given and the shear stress also available. In problem the width also not given. So, here you can take L into W. So, here W you can take 16 mm and shear strength is 42 Newton for 42 megapascal and D already you know. So, in this 16 has taken. So, already you know the rectangular key dimensions are width and thickness. So, the width is equal to D by 4. So, where D is diameter of the shaft and thickness you can take D by 6. Clear? So, here D is given D is 50. So, 50 by 4. So, apply this one. So, with the empirical relation and calculate torque. And torsional shear strength and torque transmitted by the shaft. So, the torque is equal to 5 by 16 into tau into d cube. So, you will get the shear strength, torsional shear strength. From these two equations 1 and 2 you will get length. Equate these two equations, so you will get L is equal to 61.31. Now considering the crushing of the key, we know that the shearing strength or torque transmitted of the key T is equal to L into T by 2 into sigma C. So that is the compressive stress already given in our problem. So here thickness is 10 and sigma C 70. So substitute those values, you will get the torque. From these two equations we have the L value we got, that is 117.7 mm. So taking larger of these two values, you have length of the key. So which value is higher? So first one is in first case, when considering shear strength, so L is equal to 61.31. When considering crushing, the L is equal to 117.7. So that this value is a larger value. So you can fix as final length of the key. So that is 117.7. You can take the standard value length of the key as 120 mm. So like this have to calculate the dimensions of the key. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.